Okay, so in this one we're going to look at question 4 from the NHT Further Maths Exam 2 from 2019. So we've got a scatter plot. It's plotting the variables lifespan and sleep time for 19 different mammals. We're making the assumption that this is linear. A least squares line is fitted to the started with sleep time as the explanatory variable. The equation of that least squares line is given here. Okay, the coefficient of determination is 0.416. All right, draw a graph of least squares line on the scatter plot. To do this, you need 2 points, and the easiest ones are probably going to be 0, and this is sort of from that sleep time, so basically that x variable, the x value, sorry. You're going to pick when x is 0, so you're going to go 0, oh, that's y. You're going to have, oh, it is x, sorry, my bad. And x is 18, so these are my points I'm after. So I want the y value, so I'm going to put this into, you calculate, so it's 42.1 minus 1.9 times 0, you're going to get 42.1. So you're going to go up to here and go 42.1. So this is going to be very rough dot there. It's about there. Okay. I know you can probably barely see it on your computer or wherever you're watching. This one here, I'm going to put as what you'd put in where sleep time is. You would put 18. And when you do that, you'll get an answer of 7.9. So I should have put 42.1. and then 7.9 there. So 7.9 is roughly about there. Okay, probably not ideal without a ruler. I mean, I've got a ruler on this I can use, but just, yeah, make sure you've got a ruler in your exam. Okay, and so all it's asking you to do really is line up 2 dots, something along those lines. Maybe slightly, probably spending too long doing this for you. It's probably close as I'm going to get. It's spending way too long, sorry. Slight there, about, way too long. Sorry, say that again. Again, this is not going to be perfect, but you get the general idea. Okay. Again, sorry about the not being particularly great on that, but you know, you got your rule on your exam. Do that. That's going to give you the mark. Okay. That's all we need to do on that one. Describe the linear association between lifespan and sleep time in terms of strength and direction. Okay. So what's been asked here is strength is your R value. So strength is R, and that's whether it, and then the direction is plus or minus. Okay, and that's what you've got to work out. All right, so R I can get from this here. So I'm going to go. So that's going to be R is going to be the square root of 0.416. If I get the calculator up, I'm going to go and put 0.416 in there, and I'm going to get a value of 0.64. So that's equal to 0.64. That means that the strength equals moderate. Now you just need to say strength is moderate. It will go moderate in direction. I'm just showing you how to do it there. The direction. Now, if you get an R value in a different sort of question, you'd get it as positive or negative. So what I should have put here is plus or minus, because we don't know whether it's plus or minus from that square root, but we do know the gradient here is negative, and the negative, if it's a negative gradient, that means the direction is going to be negative. So direction equals negative. Okay. So C. In interpret the slope of the least squares line in terms of lifespan and sleep time. So this is where you should have in your summary book some sort of statement that you can basically, you see a question like this and go, all right, what do I say? So basically you're going to say something like this. On average, if I spell average right, the lifespan, okay, so lifespan, so that's your, basically what's happening to your, that's your response variable. The lifespan decreases by 1.9, and I'll come back to that in a moment, for each additional hour of sleep time. The reason I said I'll come back to the 1.9, the 1.9 comes from that part there. That's your gradient. So, and it's a negative 1.9. That's why it's a decrease of 1.9 for each extra hour. Every time you go, you put an hour, it's 42.1 minus 1.9 times 1. In this case, it's going to be 1.9. Then it's going to be, if this is 2 hours, it'd be 1.9 times 2. So that's going to be 3.8. So it's 42.1 minus 3.8. It's each hour is an additional 1.9 hours. Okay? So that leads on to D. Interpret the coefficient of determination in terms of lifespan and sleep time. Now, again, this is a statement you should have in your summary book. And basically it says, so what it's saying is it's going to say the percentage, we'll get to that, in the variation in the response variable can be explained by the variation in the sleep time. So what does that mean? I take that 0.416 and I convert it to a percentage, so I multiply it by 100. That gives me 41.6%. Okay, of the variation in the response variable, that's lifespan. Can be explained by the variation in sleep time. That's our explanatory variable. Okay, this statement, put this statement in your summary book. You can just say percentage, whatever that happens to be. Lifespan, in this case, is response variable. Response variable. And this is your explanatory variable. Sorry, I did have to sound that out to spell it. Okay, so that's what you need, something like that in it. And the key, another key point in this is it's the variation and the variation. You need those two variation terms in there. Okay. E, the lifespan of the mammal with a sleep time of 12 hours is 39.2 years. Show that when the least squares line is used to predict the lifespan of this mammal, the residual is 19.9 years. So remember how to calculate residual. I'm just going to put residual. I should have gone back to green, shouldn't I? Oops. Residual equals y actual minus y predicted. All right. So y actual, we've got that. So that's 39.2. Now, what's y predicted? Well, we need to use the equation we got before, which was y predict equals 42.1 minus 1.9, and we've told that our sleep time is 12. Okay, so that's times 12. So just to be clear, that 12 is what I've used there. So 42.1 minus 1.9 times 12. All right, that gives me a value of 19.3. So that's what I put here. I just go 19.3. And just to check that, if we get the calculator up, 39.2 minus 19.3 is going to give 19.9, and we've just finished that answer. Okay, so that's question 4 done. Bye.